the second part of our complementary angles, or our 2.4, sorry, right, trig ratios with right triangle properties. All right, the next thing we're going to look at is complementary angles. And complementary angles are angles that add to 90 degrees. For example, 30 and 60 degree angles are complementary angles. Okay? One thing to note is that the acute angles in a right triangle are complementary, okay, always. And that's because all triangles add up to 180. So if one of them is a 90 degree angle, then the other two also have to add up to 90 degrees, right? So no matter what, the acutes, so the angles that are not the right angle, will add up to 90. So that's all this picture is showing, right? That this and this, they do add up to 90, and they would be complementary angles. And the other thing it's showing us is that if one is x, then the other has to be 90 minus x. And we'll kind of use that idea later on too. Okay, so looking at our first triangle here, right? I have this triangle ABC, and I'm going to find the sine of A, the sine of C, the cosine of A, and the cosine of C. Okay, so starting with sine of A and cosine of A, if I'm looking at angle A, we have our hypotenuse, the opposite side, and then our adjacent side. So sine is O over H, which is 4 over 5. And cosine is A over H, which is 3 over 5. Okay. Now, if I look at sine of C, right, I have to look at this angle, meaning I still have my hypotenuse, but my opposite side changes, and so my adjacent side changes. All right, so you have to be very careful. So now my sine of C is O over H, which is 3 over 5. And my cosine of C is A over H, which is now 4 over 5. Okay. Same kind of thing for this triangle. However, I have a missing side here. So I am going to do C. My Pythagorean's theorem, a squared plus b squared equals c squared. So that's a squared plus 8 squared equals 17 squared. A squared plus 64 equals 289. Subtract 64 from both sides, and we get a squared equals 225. Square root a equals 15. So now that I have all three sides, I know no matter what, I'll be able to find my trig ratios, right? So if I'm looking again, sine of A, our hypotenuse, our opposite side, and so then our adjacent side. So sine is O over H, which is 8 over 17, and cosine is A over H, which is 15 over 17. Again, switching our trig ratio, or switching our angle. And now our hypotenuse stays the same, right? But our opposite side and our adjacent side switch. So really what's happening is our sine and our cosine switch, right? So with these two examples, that's what you should notice. You should notice that the sine of one is equal to the cosine of the other. Those are the same. And same thing this way, right? So the sine of one is equal to the cosine of the other. Same thing here, that sine and that cosine are equal, and this cosine and that sine are equal. Okay? This is what we call our complementary angle theorem. So our complementary angle theorem says the sine of one angle is equal to the cosine of the complementary angle. Okay? And vice versa. The cosine of an angle is equal to whatever, right? So the sine of an angle is equal to the cosine of the complementary angle. So for example, if I have the sine of A, right, it's sine, right, so the sine of one angle is equal to the cosine of the complementary angle. So this was A, and the complementary angle is B. Okay, so sine of A is equal to cosine of B. The trig ratio switches and the angle switches. Same thing here, it was sine of B is equal to the cosine of A. Same thing here, it was cosine of A is going to equal the sine, and then I switch my angle, of B. And the cosine of B, cosine switches to sine of A. Okay, so the trig ratio switches and the angle switches. Another way, I'm going to just add in one type of problem. Something else you might see is that, that's not how you would write that. Example 2. There we go. You might see something that looks like this. Sine of 85 equals the cosine of x plus 5. Okay? Well, what do I know? I know that these are complementary angles, so these add up to 90. This is a weird problem, that's okay. Chose dead numbers, that's okay. So to solve this, right, I'm going to combine these because they're on the same side. 90 plus x equals 90. Subtract 90. And x just happens to be 0. Okay, so you can kind of have this other type of problem you might solve if you know that these things are the same. All right. That is it. Have a good rest of your day, and I will see you guys tomorrow.